All right, so we're going to pick up with problem number 6 that I left off on with the last video. And as I said in that last video, we're going to use two things to take this derivative. We're going to do the chain rule because we have this function being placed in this outside function. That's the chain rule. And we also need to use the quotient rule because we have a fraction. So that's what we're going to do. We're going to use the chain rule and the quotient rule to take that derivative. First, I'm going to use the chain rule. And this stuff right here, all this stuff, that's your inside function. I'm going to replace it with a box just to kind of make it clear what I'm doing. This stuff right here that I'm going to ignore for a second, which is this stuff right here, it's my inside function. And it's being brought to the fourth power. This is my outside function, something to the fourth power. First thing you do in the chain rule is you take the derivative of the outside function. Well, this is your outside function. I'm going to take its derivative. To do that, I'm going to use the power rule. So I'm going to bring this 4 to the front. So I'm going to have 4, whatever this inside function is. And then I'm going to subtract 1 from my exponent cubed. That's the derivative of my outside function. 4 something to the third power. That's the derivative of my outside function. Well, we have to evaluate that at the inside function. That's your chain rule. Take the derivative of the outside function, evaluate it at the inside function. Well, the inside function is this stuff right here. So that goes in your box. T minus 4 divided by t plus 4. Okay, that's the first part of your chain rule. Take the derivative of the outside function, evaluate it at your inside function, but then we have to multiply this by the derivative of the inside function. So I have to take the derivative of this stuff right here. Well, that is a quotient. So I have to use the quotient rule. And the quotient rule, the quotient property, remember from our last video from yesterday? It was this whole thing right here where I have low d high minus high d low all over low squared, where high is the top of your fraction, low is the bottom of your fraction, and that d means derivative. So I'm just going to start plugging that stuff in. Low, that's the bottom of your fraction, t plus 4. So I'm going to have, I hate when they use t's because it looks like a plus. It's going to be t plus 4. That's your low. I think we're going to run out of room here. I better start writing smaller. That's your low. Then I have d high. D high is the derivative of the top. The derivative of the top is just 1. And I talked about this in the last video from yesterday, but the derivative of this whole function is just 1, because the derivative of t is 1, and the derivative of any number is just 0. So the derivative is 1 minus 0, which is 1. So the derivative of your top function is just 1. So I'm going to have 1. Then I have this minus. Then I have high. High is your top. It's going to be t minus 4. And then I have d low, which is the derivative of the bottom, because low is the bottom. Derivative of the bottom. Derivative of the bottom is just 1, because the derivative of t is 1, and the derivative of any number is just 0, so it's 1 plus 0. Derivative of the bottom is 1. So that's going to be a 1. And then I'm going to simplify this a little bit. I'm going to just drop this part down right here. I'm going to simplify that second part. If I have t plus 4 times 1, anything times 1 is just itself. So that's just t plus 4. Then I'm going to drop down my minus. And again, anything times 1 is just itself. So t minus 4 times 1 is just t minus 4. And finally, I'm going to distribute this negative times a positive t. And I'm going to drop down that first part. T plus 4. Then I'm going to distribute this negative. Negative times a positive t is a minus t. And negative times a negative 4, negative times a negative is a positive. So that's going to be plus 4. Oops. Going to be plus 4. And finally, t right there, minus t, that's 0. The t's are gone. T minus t is 0. And then I have 4 plus 4 is 8. So this whole thing right here goes down to an 8, as we just showed. If I were to simplify all of this, which I just did here, it all goes down to an 8. Over, oh my goodness, over, look at that. Remember? Low squared. Okay? So that has to all be over the bottom squared. Don't forget that part. Easy to forget. It's all over low squared. Okay? So the top, that was that whole thing I did down here. It simplifies to 8. But then our quotient rule says it's all over low squared. So it's all over t plus 4 squared. So your final answer is just that. It's this first part right here that we got when we first started the problem. 4, I'm going to replace my box with parentheses. T minus 4 over t plus 4 cubed times that top went down to an 8. All over low squared, which is t plus 4 squared. And that's your answer. Let's see if we can find that in our choices. Looks like it's going to be this one. Let me just make sure everything checks out. T cubed 8. Yeah, that's it. So it's this one right here. It looks complex, quite a few steps, but it just takes practice. If you practice that, you get used to all the steps involved, and it's not nearly as hard as it looks. But to recap, first thing I did, chain rule. The chain rule. And the chain rule says I take the derivative of the outside function. The outside function is something to the 4th power. So I took the derivative of that outside function. I brought the 4 to the front, and I subtracted 1 from that to get that. That was the derivative of the outside function. Then I evaluated it at the inside function times the derivative of the inside function. So I had to take the derivative of this stuff right here. And that was the quotient rule, which was low, bottom, times the derivative of the top, minus top, times the derivative of the bottom. That's where this came from. All over low squared, which is the bottom squared. Then I simplified the top. All that goes down to 8. And that's where I get this right here. Okay, so it's a lot of steps. Takes a little bit of practice. At first, it looks a little bit overwhelming. But again, if you have any questions, email, Zoom. In fact, today is really the last day I have to go into school. So after today, I'm gonna have nothing but free time. So we need to get on Zoom. I can ensure that you know how to do all this, and that you're gonna do well in the class. All right. So let's start getting on Zoom after today, because I'm gonna have lots of free time. Let's go to our next one. Where is it at? Here it is. Well, that looks familiar. Oh, this one's a little different. Yeah, that's different, because this one's different because here you have the top is brought to the fourth power and the bottom is brought to the fourth power. The last one, it was just everything's brought to the fourth power. So that's how it's different. And to do this one, there's lots of ways to do it. Let me think. Okay. You're going to have to use the chain rule, because you have a function inside of a function. And you also have a function inside of a function down here. So you're going to have to use the chain rule on this one for sure. Chain rule. And then let's go through the other ones. Because remember, we can use combinations of chain rule and quotient rule and chain rule and product rule. I know I got to use chain rule because I see a function inside of a function. Product rule, I don't have anything multiplied by something else, so I won't do the product rule. And then I have the quotient rule. Quotient rule comes into play whenever you have a fraction. So yeah, I got a fraction. At some point, I'm going to have to do the quotient rule. So I need the quotient rule also. And that is it, because those are the only combinations I can do. I'm also going to be using simple, but it's not one of our combinations. It says some functions may be combos of PC and QC, but those are the only two combos you can do, is QC and PC. So yeah, I'm going to be using simple in the process of doing it, but we don't have to show that because that's not one of the combinations I can pick. So that is the answer on that one: quotient and chain. And this is problem 8. It says, we have seen that there are two ways of writing the function in the past few problems. We have, this is the first one we saw a couple problems ago. And this is the second one we saw. It was just the last problem. You see the difference. This one just has a 4, and this is being brought to the fourth power. This one right here, this is being brought to the fourth power. And this is being brought to the fourth power. Which of the following statements are true? So I'm reading this part right here. About the manner in which you would differentiate the function. Select all that apply. So let's walk through this carefully. Option 1 and option 2 both use the same rules. Okay. Option 1, option 2 use different rules. Option 1 uses the quote. I'm just reading through them first. Haven't seen it yet. Option 1 uses the quotient rule first and uses the chain rule while implementing the quotient rule. Option 1 uses the chain rule first and uses the quotient rule while implementing the chain rule. Okay. Option 2 uses the quotient rule first. Okay, we got to be careful. Let's jump down to this one. Option 1, so you're talking about this, uses the quotient rule first and uses the chain rule while implementing the quotient rule. Well, option 1 we did. Remember, that was a couple problems ago. And to do that one, you do the chain rule first. You do the derivative of the outside function. That's the chain rule. Evaluate the inside function times the derivative of the inside function. And it's at that point that we use the quotient rule. So option 1 right here uses the chain rule first and then uses the quotient rule. That was the problem that we did about 2 problems ago. And we used the chain rule, then we used the quotient rule. So that mixes it up. It's not this one. Option 1 is going to use the chain rule first. And let's see, going down to our next one. Option 1 uses the chain rule first and uses the quotient rule while implementing the chain rule. Yeah, that's what we did. 2 problems ago, that's exactly what we did. We did the chain rule first on this one right here. We did chain rule, and then we did the quotient rule. That was the order we did. Chain rule, and then we used the quotient rule in our second part of doing the chain rule. So yeah, that's exactly what we did 2 problems ago. Option 2 is the new way to write it, this right here. And it says option 2 uses the quotient rule first and uses the chain rule while implementing the quotient rule. Okay? And going down here, it says option 2 uses the chain rule first and uses the quotient rule while implementing the chain rule. Okay. Hold on one second. Uses chain rule first. That's a little confusing because I can see so many ways to do this one right here. And I can actually... So I'm looking at number 2, option 2, and I'm thinking about these 2 choices. And it's not worded very well. Let me think about that for a second. Option 2 uses the quotient rule first and uses the chain rule while implementing the quotient rule. Yeah. Yeah, I mean, you could absolutely do that. You could use the quotient rule first, where I take low, the derivative of this, and in taking the derivative of this, the high, low, d high, in taking the derivative of this, I would have to use the chain rule. Then I would go minus high, d low, and in doing that, I would have to use the chain rule. So yeah, this is definitely an option. You would use the quotient rule first, and then you would use the chain rule while implementing the quotient rule. That is certainly an option. And it says here, option 2 uses the chain rule first and uses the quotient rule while implementing the chain rule. Oh, I see. Okay. This last one, I could use the chain rule first. I could use the chain rule on the top. I could bring the 4 out to the front, take the derivative of the outside, times the derivative of the inside. And then I could also do the chain rule on the bottom. That's an option. Yeah, I could do the chain rule first. But in using the chain rule, when I take the derivative of the top, for instance, if I were to do the chain rule on just the top, I wouldn't use the quotient rule while implementing the chain rule. So yeah, that's not an option. I actually wouldn't do that. Because if I were to do the chain rule first on this one, I would just do the chain rule on the top, and then I would do the chain rule on the bottom. But while doing the chain rule, I would not be implementing the quotient rule. So yeah, that one takes a little bit of thought to rule out option 2. And when we get on Zoom, I can discuss that a little bit further. But yeah, it's these 2. So it's 2. And let's see what else we got here. Okay. Here's question 9. On question 9, we got a fraction. So I'm looking at this one right here. Got a fraction. So I know I am going to be using the quotient rule. Got to use that quotient rule. And let's look at our other ones. Chain rule. On this one, I don't see a function being put inside of another function. So I don't... You remember, that's when we used the chain rule. So if you look back at the last problem, here, I can clearly see this function is being put into something to the fourth. Or on this one, I can see that this function is being put into something to the fourth. I don't see anything like that on this problem. I just have a function on the top, but that function hasn't been placed in another function, and I have a function on the bottom, but that function hasn't been placed inside of another function. So I don't see anywhere where I put one function inside of another function. So I'm not going to be using the chain rule. And let's see, we can also do combinations. It says we can do PC or QC. And right here, so I know it's the quotient. I know it's not the chain because there's not one function inside another. Product rule, that's interesting because technically this on the bottom, I mean, you could see it as an application of the product rule. 3 times z is a product. And if you were to use the product rule on 3 times z, you would get the right answer. You would actually get the right answer if you were to use the product rule. It is a product. Product multiplication. 3 times z is a product. And if you were to use the product rule on 3 times z, you would get the derivative of that. But the thing is, you don't have to use the product rule on this because there's another property. If I just have a number times a variable, I can just take the derivative. I wonder what the one on this one. I mean, strictly speaking, yeah, you could use the product rule on it because it is a product. But I am not thinking they want you to put that. I think they just want you to put the quotient rule. Because when you take the derivative of this, you don't have to use the product rule. So I'm thinking it's just the quotient rule. That's a little tricky. It could possibly be a P and a Q, but I'm thinking they just want the quotient rule on that. I'm thinking they just want the quotient rule on that one. That one's a little tricky, exactly what they want on that. So yeah, you could argue both ways. You could say, yeah, I could do the product rule on the bottom. And if I did the product rule on the bottom, I'd get the right answer. But you don't have to use the product rule on the bottom. So, and you can still get the right answer. But I'm going to say it's just the quotient rule on that one. Okay, and now we actually got to take the derivative of that, and we're going to use the quotient rule. So we are going to go low d high minus high d low all over low squared. That is your quotient rule. Now let's just go through it. Low, it's your bottom. It's going to be 3z. And then we're going to have d high. That's the derivative of your top. Remember, derivative of a number, this number right here, that's just 0. So we can ignore it. We just need to take the derivative of z squared. And that's just your power rule. Bring the 2 to the front. It's going to be 2z. And then subtract 1 from the 2. So the derivative of the top is just 2z. That's your d high, derivative of the top. And then we got your minus right there. So drop that down. Then we have our high, which is your top. So I'm going to write down my top. Z squared plus 1 times d low, which is your derivative of the bottom. Derivative of the bottom, if you just have a number times a variable, you don't see if you just have a number times a variable and your exponent's 1, because if you don't see an exponent, it is 1. If you have a number times a variable to the first power, the derivative is just the 3. It's just that 3 right there. You can ignore that z. Your derivative is just 3. That's your d low, all over low squared, which is your bottom, 3z. squared. And of course, they're going to simplify it, so we need to simplify it because you don't see that choice here. I mean, yeah, that's your derivative. But we got to simplify it until it matches one of our choices. And let's see what we got here. 3z... 3... Yeah, they simplified the top. So let's go ahead and simplify the top. If I start here, I'm going to multiply these two things together. 3 times 2. That's going to be 6. And then I got z times z. That's going to be z squared. Then I'm going to drop down this minus. And I'm subtracting this whole thing. So I need to put parentheses because I'm going to subtract everything in these parentheses. I'm subtracting all this stuff. So I need to subtract all this stuff. So I need to put it in parentheses. And then I'm going to distribute my 3. 3 times z squared is 3z squared. And 3 times 1 is 3. And there's a plus between them. So I got that right there. And all of that's going to be over. Nothing's changed on the bottom yet. In fact, let's go ahead and change the bottom because I think they've changed it in their answer choices because I'm kind of looking to see what they have. If I take 3z squared, remember if you square anything, like if I say, forget that problem for a second. If I say 5 squared, that's going to be 5 times 5. Okay, that's just to show you what square means. Well, if I have 3z squared, that's going to be 3, that's messy. That's going to be 3z times 3z. 3 times 3 is 9. Z times z is z squared. So if you go 3z squared, you have to square the 3 and the z. It's going to be 9z squared. And that is a z. And there's a little bit more we can do. We can also distribute this minus. Okay, we can distribute that minus. So it's going to be 6z squared. This negative times the 3z squared. I'm going to treat it like a negative. Negative times 3z squared. Well, that's positive. Negative times a positive is a negative. So it's going to be minus 3z squared. And then I have this, I'll treat it like a negative. Negative times a positive is going to be a negative. So it'll be minus 3. All over 9z squared. And finally, I can do a little bit more simplification on the top. I have 6z squared minus 3z squared. So right here I have 6 z squares. Right here I have 3 z squares. And if I subtract them, I had 6, I take away 3 of them. I now have 3 z squares. So I have 3 z squared. That was combining these two. Then I still have this, minus 3, all over the bottom, which is 9z squared. And that's your answer, right there, which is this one. It's your last one. Okay. Was that it? It seemed like there was more. No, I think that's it. Yeah. Okay. Yeah, that's it. So go ahead, look over those videos, and like I said, let's start doing some Zooms because the last day I have to go into school is basically today. So after today, all I have is free time, and I can do as many Zooms as you want, and you can ask all the questions you might have, and we can ensure that you're going to do well in this class. All right? So I'll talk to you later.